Hello, dear students. How are you? Make sure the screen is visible to you and I'm audible. Give me yes in the chat box, then we can start this session. Trisha and Dheeraj, you both are present here. Okay. So in the previous session, what we have did in the previous session, we have seen some of the application of center of mass. Okay. Like center of mass for continuous bodies. In the previous session, we have seen what is the value of center of mass for ring, and that ring is semicircular. Okay, no? Then we have seen it for disk. Okay. So previous session में we have seen it. If I have a ring which is semicircular और इसका रेडियस इज कैपिटल आर, तो उसका सेंटर ऑफ मास क्या होगा? 2r/5, और ये होगा y सेंटर ऑफ मास. ठीक है. इसका x सेंटर ऑफ मास और z सेंटर ऑफ मास क्या होगा? 0. सिमिलरली फॉर डिस्क, वो भी क्या, सेमी सर्कुलर. तो डिस्क के लिए हमने क्या देखा था? सेंटर ऑफ मास ऑफ डिस्क इज 4r/5. सॉरी, 2r/3 pi. So 2/3 times of center of mass of ring. ठीक है. So this is what we have seen in the previous session. Although for hollow semi-sphere, this is hollow semi, or you can say hemisphere. इसका सेंटर ऑफ मास कहाँ था? y सेंटर ऑफ मास इज r/2, हाफ ऑफ द रेडियस. लेकिन अगर इसे ही मैं सॉलिड कर देता हूँ, इफ आई कंसिडर इट अ सॉलिड हेमिस्फीयर, then center of mass of the solid will lie at 3r/8. ठीक है. और क्या हमने डेरिवेशन भी किए थे और इनका इलेबोरेशन भी किया था दोनों को. ठीक है. नाउ टुडे, तो इसके अलावा एक टॉपिक और डिस्कस किया था, दैट इज कंजर्वेशन ऑफ लीनियर मोमेंटम. ऑफ सेंटर ऑफ मास। कंजर्वेशन ऑफ लीनियर मोमेंटम सिस्टम सेंटर ऑफ मास में हमने क्या देखा था कि अगर external force on the system is zero, then we can say that acceleration of center of mass is zero. If acceleration is zero, then velocity of center of mass is zero, or specifically the change in velocity. Okay? If system is at rest initially. Initially system क्या था? रेस्ट में था. Then we can say the velocity of center of mass finally will become zero. ठीक है? If the velocity, final velocity is also zero, initial velocity is also zero, then we can say that the change in displacement of center of mass position is also zero. And since initially it is at rest, so we can say that xcm is equals to zero, which means there is no change in the position of center of mass. Center of mass जहां था वहीं पे ही रहेगा. Clear? So this is what we have seen in the previous class. Now, in today's class, we are going to solve some problem related to conservation of linear momentum about center of mass, and we will see the concept of collision also. Okay. Now, so first of all, we will discuss some question related to the concept that we have learned in the previous class. So in this question, if you will see, a man of mass small m stand at the left end of a plank of length capital L and mass capital L, which lies on a frictionless surface of ice. If the man walks to the other end of the plank, then by what distance does the plane slide on the ice? तो यहाँ पे इस सिस्टम में कौन कौन है? फर्स्ट ऑफ ऑल सिस्टम हम डिसाइड करेंगे. ठीक है. इस सिस्टम में है मेरा ये बॉय है और ये प्लैंक. ठीक है. क्लियर है? सिस्टम. ठीक है. सिस्टम में मेरा क्या हो गया? एक बॉय हो गया और ये प्लैंक हो. ये जो आपको दिख रहा है दिस इज आइस. तो ये फ्रिक्शनलेस सरफेस होगी जिसका फ्रिक्शनल कोफिशिएंट क्या है? जीरो. ठीक है. क्योंकि ये मेंशन भी किया हुआ है दिस इज अ फ्रिक्शनलेस सरफेस ऑफ आइस. इफ द मैन वॉक्स टू द अदर एंड ऑफ द प्लैंक देन बाय व्हाट डिस्टेंस डज द प्लैंक स्लाइड ऑन द आइस. अब इनिशियली द एफ एक्सटर्नल इज जीरो. ठीक है. इनिशियली एफ एक्सटर्नल इज जीरो. देर इज नो एक्सटर्नल फोर्स ऑन द सिस्टम. कोई भी फोर्स नहीं. द ओनली फोर्स दैट प्रेजेंट हियर इज द वेट ऑफ द मैन which is balanced by the normal reaction provided by the block. ठीक है. Clear? So these forces considered to be internal. So there is no external force in the system. Now, so what we have seen, if external force is zero, the momentum is conserved. If the momentum is conserved, there is no change in acceleration. If there is no change in acceleration, the velocity would be constant. And if the velocity is constant, there is no change in the position of center of mass. ठीक है. तो सेंटर ऑफ मास की जो पहली पोजीशन थी वो एज इट इज रहेगी. ठीक है. क्लियर है? अब इनिशियली हमें पता है इस तरफ से जो प्लैंक है वो थोड़ा हैवी, क्योंकि यहाँ पे बॉय भी खड़ा है और प्लैंक का भी कुछ मास है। सो जो मेरा सेंटर ऑफ मास है वो हेवियर मास की तरफ जाएगा। यहाँ पे मेरा सेंटर ऑफ मास था इनिशियली, दिस इज द पोजिशन ऑफ सेंटर ऑफ मास। ठीक है, दिस इज द पोजिशन ऑफ सेंटर ऑफ मास। अब देखो, ये मूव किया, इसके मूव करने के बाद ही इस पोजीशन पे आ गया अदर एंड पे, लेकिन मेरा सेंटर ऑफ मास वहीं पे है, शिफ्ट नहीं हुआ। सो ऑब्वियसली इस प्लैंक को दूसरी साइड पे मूव करना पड़ेगा। ठीक है, लेट मी जस्ट रीड्रॉ दिस। ठीक है, तो सेंटर ऑफ मास की पोजीशन चेंज नहीं होगी एज लॉन्ग एज देर इज नो एक्सटर्नल फोर्स ऑन एक्टिंग ऑन द सिस्टम। ठीक है। जैसे ही एक्सटर्नल फोर्स ने एक्ट करना शुरू करेगा तो पोजीशन विल बी डिस्टर्ब, बट इन दिस सिस्टम देर इज नो एक्सटर्नल फोर्स। तो यहाँ पर जो सेंटर ऑफ मास की पोजीशन है वो चेंज नहीं हो, नो चेंज। ठीक है, क्लियर। अब देखो, सपोज ये जो प्लैंक है अपनी इनिशियल पोजीशन, यहाँ पे प्लैंक की इनिशियल पोजीशन, यहां से इसका जो डिस्प्लेसमेंट हुआ दैट इज एक्स। ठीक है, सो लेट मी राइट इट हियर, डिस्प्लेसमेंट ऑफ प्लैंक इक्वल्स टू एक्स। ठीक है, अब अगर डिस्प्लेसमेंट प्लैंक का एक्स हुआ है तो इसका डिस्प्लेसमेंट कितना होगा? अगर प्लैंक की लेंथ एल है तो मैन कितना मूव किया होगा? जाहिर सी बात है, डिस्प्लेसमेंट ऑफ मैन इज इक्वल्स टू एल माइनस एक्स, बट नेगेटिव वे में। अबाउट द सेंटर ऑफ मास दोनों ऑपोजिट मूव कर रहे हैं, एदर यू कंसिडर द डिस्प्लेसमेंट ऑफ प्लैंक नेगेटिव और डिस्प्लेसमेंट ऑफ मैन इज नेगेटिव। नाउ वी नो दैट change in center of mass is equals to 0, and change in your displacement of center of mass, how we write it? m1 x1 plus m2 x2 divided by m1 plus m2 is equals to 0। मैंने कितना मूव किया है? l माइनस एक्स। ठीक है, नाउ यहाँ पे हम कह सकते हैं m1 x1 plus m2 x2 is equals to 0। m1 is the mass of man which is small m, displacement of man is x minus l, माइनस को अंदर मल्टीप्लाई कर दी, प्लस m2 इज मास ऑफ प्लैंक एंड डिस्प्लेसमेंट ऑफ प्लैंक इज स्मॉल एक्स। ठीक है, दिस डिस्प्लेसमेंट इज रिलेटेड टू आइस। ठीक है, तो यहां से x की वैल्यू कितनी आ जाएगी? इफ यू जस्ट मल्टीप्लाई इट इनसाइड, स्मॉल एम एक्स माइनस स्मॉल एम एल प्लस कैपिटल एम एक्स इज इक्वल टू 0। नाउ x would become small m up into capital L divided by total mass of the system। ठीक है, सो दिस वुड बी द डिस्प्लेसमेंट ऑफ द मैन विद रेस्पेक्ट टू प्लैंक। ठीक है, विद रेस्पेक्ट टू प्लैंक अगर आप देखोगे तो कितना डिस्प्लेसमेंट है? एल माइनस एक्स, है ना। तो ये डिस्प्लेसमेंट कितना किसका है? प्लैंक का है, मैन का डिस्प्लेसमेंट कितना होगा? एल माइनस एक्स, लेट से एक्स डैश इज इक्वल टू कैपिटल एम इंटू एल डिवाइडेड बाई स्मॉल एम प्लस कैपिटल एम। यहां से एक रिलेशन हमें बन रहा है कि पोजीशन ऑफ सेंटर ऑफ मास ऑफ center of mass is inversely proportional to the mass of system, mass of the object। देखो, जब प्लैंक का डिस्प्लेसमेंट देख रहे हैं तो नोमरेटर में क्या आ रहा है? मास ऑफ मैन। जब मैन का डिस्प्लेसमेंट देख रहे हैं तो नोमरेटर में आ रहा है मास ऑफ प्लैंक। सिमिलर में हम वेलोसिटी ऑफ प्लैंक भी लिख सकते हैं, विच इज दिस इज द डिस्प्लेसमेंट ऑफ प्लैंक, सो वी कैन राइट इट स्मॉल m अपॉन small m plus capital M into velocity of Planck with respect to ground, ठीक है, with respect to ice, इनिशियल वेलोसिटी जो भी गिवन, ठीक है। सिमिलरली ये हम इसे वेलोसिटी ऑफ सेंटर ऑफ मास भी नहीं बोल सकते, बिकॉज वेलोसिटी ऑफ सेंटर ऑफ मास तो जीरो। नाउ वेलोसिटी ऑफ मैन माइनस कैपिटल एम अपॉन स्मॉल एम प्लस कैपिटल एम इंटू यू, जो भी उसकी इनिशियल वेलोसिटी, ठीक है। सो इन्हें नोट कर लो आप दोनों। Move on to the next. A nucleus at rest disintegrates into two daughter nuclei with no other particle emitted in the decay. The masses of nuclides formed are m1 and m2, and the energy released is capital Q. What is the magnitude of momentum and kinetic energy of two particles? Look into the solution of this question. So मेरे पास एक हैवी न्यूक्लियस था, ठीक है। दिस इज द न्यूक्लियस एंड विच इज इनिशियली एट रेस्ट, ठीक है। रेस्ट पे होने की वजह से देर इज नो एक्सटर्नल फोर्स, इनिशियली एट रेस्ट। उसके बाद इंटरनल प्रोसेसिंग हुई, देर इज सम इंटरनल फोर्सेस एक्टिंग, जिसकी वजह से दिस न्यूक्लियस कन्वर्टेड इनटू टू डॉटर न्यूक्लियाई, ठीक है। ये जो डिसइंटीग्रेशन हुआ, दिस इज अ इंटरनल प्रोसेस, इंटरनल प्रोसेस, ओके। ये क्या है? इंटरनल प्रोसेस। यहाँ पे इस पार्टिकल का जो मास है, जो भी न्यूक्लियाइड्स बने, दीज आर m1 एंड m, इनका मास क्या है? m1 एंड m, ठीक है। अब डिसइंटीग्रेशन हुआ है तो इन दोनों पार्टिकल्स के पास भी कुछ ना कुछ एनर्जी आई हो, बिकॉज इन द डिसइंटीग्रेशन प्रोसेस देर इज अ रिलीज ऑफ एनर्जी, और उसकी बात ये यहाँ क्वेश्चन में भी कर रहा है, देर इज अ रिलीज ऑफ एनर्जी ऑफ क्यू। नाउ what is happening, can we say that the momentum is conserved in this process? Yes, we do, because this process of integration is internal process, so whatever is happening internally. In this case there is no external force present. If there is no external force, if external is equals to zero, then we can say if external is equals to zero, in this case we can say momentum is conserved, Okay. If momentum is conserved, which means whatever the initial momentum is, same will be the final momentum. So we can say that P initial of the system is equals to P final. Initially, there is a nucleus which is at rest. So there is no velocity, there is no momentum. Finally, it disintegrates into two daughter nuclei. Two daughter nuclei. Let's say one of them having velocity v1 and another having velocity v2. Okay. So initially the momentum is zero because it is at rest. Finally, the momentum will be m1 v1 plus m2 v2. We can say that. Okay. Now, can we say that m1 v1 is equals to m2 v2? Vectory, because when they disintegrate, the center of mass remains same. So for that, they will move in the opposite direction, as we can see here also. So v1 is minus v2, which means v1 की जो direction है v2 की exactly opposite. So we can say that the momentum are equal. P1 and P2 are equal magnitude wise. So magnitude of P1 and P2 are equal, which is equals to P, let's say. Okay. So what we can do here? What is the kinetic energy of the system? Kinetic energy of the system is the energy released given in the question. Energy released is capital Q. Okay. So whatever the energy released, these particles having this energy in the form of kinetic energy. Okay. So we can say that Q is equals to K1 plus K2, the kinetic energy of these two daughter nuclei. Okay. So Q is equals to 1 by 2 m1 v1 square plus 1 by 2 m2 v2 square. Now in this case, can we write kinetic energy in the form of momentum? Yes. The expression of kinetic energy in the form of momentum is K is equals to P square upon 2m. So we can do it for this one and this one also. So Q is equals to P1 square upon 2m1 plus P2 square upon 2m2. Okay. Now P1 and P2 is equal and this is the magnitude. So we can say that Q is equals to P square by 2 into 1 upon m1 plus 1 upon m2. So we can say that twice of Q is equals to P square into m1 m2 by m1 plus m2. Take the LCM m1 plus m2 divided by m1 m2. ठीक है. यहाँ से P की वैल्यू मेरे पास क्या आ गई? P is nothing but square root of 2 times of m1 m2 upon m1 plus m2 into Q. So this is the momentum. Now for kinetic energy, you can put this expression in K1 as K1 P1 square by 2m1. You will get the kinetic energy K1. For kinetic energy 2 of this particle, you need to put this as K2 is equals to P2 square upon 2m2. And what you will find that kinetic energy is inversely proportional to the mass of the system here in this case. Okay. देखो, if you just calculate the value of K1 here, K1 is nothing but P1 square by 2m1 and P1 square is P square, which is 2m1 m2 upon m1 plus m2 into P. 2m1 m2 upon m1 plus m2. One of the denominator we also have 2m1 if we talk about K1 into Q. m1 2 will cancel out. So K1 will be independent of the mass of that particle. Okay. m2 upon m1 plus m2 into Q. This is the value of Q. So for K1, it will depends on another mass, which is V2. For K2, it will depends on the M1. ठीक है, oppositely dependency. Clear? So this concept you can apply for each and every process. ठीक है, each and every process के लिए you can apply this. So you can say that K1 upon K2 is equals to M2 upon M. ठीक है. So now move to the next question. This one. A man of mass small m climbs a rope ladder suspended below a balloon of mass capital M. The balloon is stationary with respect to ground. If a man start climbing the rope ladder at a speed capital V with respect to ladder, then find the speed of balloon with respect to ground. Okay. Now to solve this question, we just have to imagine the situation. देखो, this is a balloon we have, और इस balloon से we are having a rope ladder. ठीक है, एक rope है जिसपे एक man is climbing. ठीक है. Now initially the system is at rest. Whenever the system you find at rest and there is no external force, you just have to conserve the momentum. Conserve momentum. Okay. When men start climbing on this with a speed capital V with respect to the rope, and suppose when this man goes up, to maintain the center of mass coordinate fixed, the balloon will move into the opposite direction, let's say with velocity u, and this velocity u is with respect to ground. Okay, so velocity of man with respect to ground is given by capital V minus small e. Okay, now just conserve the momentum. Initially, P initial is equals to P final. Initially, the momentum is zero because system is at rest. Finally, the momentum will be mass of the man into velocity of the man with respect to ground, V minus small e, plus mass of the balloon, let's say capital M, into velocity of the balloon, which is in opposite direction. Okay. Now here you can say 0 m capital V minus small m small u plus this will also become minus m into minus u. Okay. Take the u common. So this will become u is equals to small m capital V divided by small m plus capital. Okay. So the velocity of man here will depend on the mass of the man directly. Okay. Clear? So these types of question you need to solve by applying the conservation of momentum principle. Okay. You just have to find out if the system is in rest or not. If the system is in rest and there is no external force, just apply the conservation principle and apply the formula or concept of center of mass. Okay. Now just move to the another question. Now we will talk about collision. What is collision? So by collision, what do we mean? Basically, it is a process of momentum transfer by the internal forces. I'll show you some GIF here. If you will see in this case, this scooterist is coming in one way. This rider is coming in another way. And when they both strike at that one place, There is a spark, there is a release of energy, and there is also a transfer of momentum. Okay? But there is no external force acting on this. Externally, nobody has disturbed the system. This whole process is internal. So that is why this collision is nothing but the process of momentum transfer by the internal forces. Okay? Because everything is made up of atom or molecules. So these atoms or molecules apply internal forces on each other to get the momentum transfer. Okay? And that is why this collision happens. Now, this image you can keep in your mind. This is also a type of collision. ठीक है? Now, concept of collision के बारे में हम बात करेंगे. Let's suppose there is a plane and we have two balls moving with different velocities. Let's say u1 and u2 vector. ठीक है? So initially what we will say, suppose they are positively charged particles. Or if you do not want that analogy, we will be having that both are experiencing a repulsive force Fr in this way. Okay. Clear? So what will happen when this force, this ball, apply a repulsive force on this particular another ball? So the force applied by this particle is in the same direction of the velocity, which means the velocity of this ball will increase. Clear? And if you will see the force applied by this ball to this ball, it is in the opposite direction of the velocity. Okay. Initially, we consider that u1 is greater than u2. So what will happen? They will come nearer to each other. Okay. And at that particular stage, the separation between them is minimum. They will not physically touch each other, but they are at a minimum distance because the repulsive force applied by the ball on each other, one of the ball is getting converted into higher velocities and one of the ball is getting converted into lower velocity. So u1 is decreasing and u2 is increasing. So in this process, u1 will slow down and it try to reach at u2. It try to quat u2. तो इस कोशिश में क्या होगा, दोनों एक दूसरे के पास आएंगे एंड दैट सेपरेशन विल बी मिनिमम. एट दिस स्टेज वी कैन सी दिस इज द मिनिमम काइनेटिक एनर्जी स्टेट. यहाँ पे वेलोसिटी भी क्या हो जाएगी, दोनों की सेम हो जाएगी. ठीक है? क्योंकि उसके बाद तो चेंज होनी. रिपल्सिव फोर्सेस ने क्या किया, एक वेलोसिटी को बढ़ाया एक वेलोसिटी को घटाया. सो एक कंडीशन ऐसी आएगी कि दोनों वेलोसिटी क्या होंगी, सेम होंगी एंड एट दैट कंडीशन दे विल बी एट अ मिनिमम सेपरेशन. उससे कम सेपरेशन नहीं पॉसिबल. एंड आफ्टर दैट दे विल मूव अपार्ट. एंड इन दिस स्टेज आल्सो F repulsive is acting. F repulsive is acting in this. So this U will get decrease and this U will get increase, which means finally the velocity, let's say v2, and this velocity is v1. So finally we can say कि v2 will be greater than v1. This is before collision. Before collision. This is after collision. Okay. And this is the stage when the separation is minimum, kinetic energy will also be minimum. Minimum. So in that way, if you will see, they are not touching each other. The misconception that we have when we study concept of collisions, we assume that everybody has to be get a contact, get a physical touch to have a collision. But it is not the case. The collision is purely a momentum transfer phenomena. So here the momentum of this ball is transferred into this ball. That is why the velocity is being different after collision and before collision. This is the pure concept of collision. If you will see the physical touch, you want that. So that collision would be impact collision. They will be categorized in a different way. Impact collision directly mean the physical impact or physical contact. Physical contact of the body. Now, in this concept, you must remember that initially there is no force on the system, because these forces, if I consider these two balls as a system, so these forces, repulsive forces, will become internal forces. So next external force on the system is zero, which means there is no change in momentum. So the momentum of this system will remain conserved. Only we can transfer the momentum of one ball to another ball or one body to another body, but we cannot have greater momentum after the collision. Okay. So momentum of the system will always remain constant. We can also have this concept here. Momentum of the system is always remain constant. Okay. Which means whatever the momentum before collision, P initial is equals to P final. Okay. Now just let's describe this phenomenon. Types of collision. What is the types of collision that we are discussing? Okay. Types of collision may, we have three types of collision: elastic, inelastic, and completely inelastic. This categorization of the collision is based on the material property. If the material is completely elastic, which means it can deform and then regain its shape again after the removal of forces, that particular collision will be elastic and that particular material will be elastic material. Then we have a partially elastic, partially plastic material. In this way, when we apply the force to that particular material, it will somehow get deformed. So some of the position or some of the deformation will be recovered, but complete recovery is not possible. So in this case, complete recovery is possible for elastic. Completely recover its shape or regain the shape. In inelastic, partially get or partially regain its shape. ठीक है ना? Partially regain its shape. For completely inelastic material, these are also termed as plastic material. So there is no gain in the shape again after the removal of forces. So if the body is deformed, they will be deformed during their entire lifetime. So these types of material we can say plastic material. Plastic material. And no gain in shape. No regaining the shape. In elastic collision, if I talk about, if you talk about elastic, inelastic, and completely inelastic, three types of collision may momentum will always remain constant or conserved, we can say. So momentum is conserved for all of them. momentum is conserved for each collision. ठीक है. Now, if we are talking about regaining the shape, so suppose मेरे पास ये कोई मटेरियल है, मैंने इस पे फोर्स लगाया, ये डिफॉर्म हुआ, मैंने फोर्स हटाया, तो ये वापस से अपनी शेप ले आया. मींस मेरे द्वारा लगाए गए फोर्स ने जितना वर्क किया, ये वर्क डन इसमें पोटेंशियल एनर्जी की फॉर्म में स्टोर हुआ. ठीक है. जैसे ही मैंने फोर्स को हटाया, उस पोटेंशियल एनर्जी जो भी स्टोर हुई थी, पोटेंशियल एनर्जी दैट विल कन्वर्टेड इनटू काइनेटिक एनर्जी, और जो मटेरियल की शेप थी वो वापस आ गई. ठीक है. विच मीन्स यहाँ पे जो काइनेटिक एनर्जी थी और जो मैकेनिकल एनर्जी थी वो भी क्या है, कंजर्व. So in elastic collision, mechanical energy is conserved. ठीक है. Before and after collision, not in between the collision. In between the collision तो change हो ही रहा है, momentum भी change हो रहा है वहां. Before and after collision, kinetic energy is conserved. ठीक है. But in inelastic collision, that is a partially elastic collision also say, you can say partially elastic collision. In this process, some of the shape you can regain. आपने फोर्स लगाया, डिफॉर्म हुई बॉडी, फोर्स हटाया, तो वो जो डिफॉर्मेशन है वो थोड़ा तो रिकवर होगा, बट कंप्लीटली रिकवरी नहीं हो. विच मीन्स वहां पे जो एनर्जी स्टोर हुई थी वो कंप्लीटली रिकवर नहीं हुई इन द फॉर्म ऑफ काइनेटिक एनर्जी. इसका क्या मतलब हुआ कि जो काइनेटिक एनर्जी थी सिस्टम की वो कंजर्व नहीं है. और वो कंप्लीटली रिकवर क्यों नहीं? सो बिकॉज ऑफ द लेटिस फ्रिक्शन. जो मॉलिक्यूल्स और जिन एटम से मिलकर के ये प्लास्टिक मटेरियल, पार्शियली प्लास्टिक मटेरियल बना है, उन एटम्स और मॉलिक्यूल के बीच में जो फ्रिक्शनल फोर्सेस हैं, इनविजिबल फ्रिक्शनल फोर्सेस, लेटिस फोर्सेस भी आप बोल सकते हो, स्ट्रक्चरल फोर्सेस भी बोल सकते हो, स्ट्रक्चरल फ्रिक्शनल फोर्स, उनकी वजह से ये शेप टोटली रीगेन नहीं कर पाता. ठीक है. तो यहाँ पे काइनेटिक एनर्जी का लॉस होगा, काइनेटिक एनर्जी लॉस होगा. अब कंप्लीटली इनइलास्टिक क्या है, इसमें तो शेप थोड़ी भी रिकवर नहीं हो पाई. जितना डिफॉर्म हुआ था आफ्टर द रिमूवल ऑफ फोर्स उतना ही डिफॉर्म है. ठीक है. तो इस तरह के केस में क्या होगा, जो आपकी काइनेटिक एनर्जी है वो तो जीरो ही हो गई ना. तो काइनेटिक एनर्जी का तो कंप्लीट लॉस हो गया. विच मीन्स यहाँ जो लॉस होगा काइनेटिक एनर्जी का, काइनेटिक एनर्जी जो लॉस होगा वो क्या होगा, मैक्सिमम होगा. इससे ज्यादा लॉस किसी भी कोलिजन में नहीं. एंड इन जनरल इन इलास्टिक कोलिजन विल टेक प्लेस, और इन इलास्टिक कोलिजन विल आल्सो टेक्स प्लेस. ठीक है. इलास्टिक कोलिजन बहुत ही रेयर केसेस होते हैं. मॉलिक्यूलर लेवल पे अगर आप कोलिजन देखोगे देन इलास्टिक कोलिजन विल बी. ठीक है. नाउ in addition to that we need to study this concept of coefficient of restitution. कोफिशिएंट ऑफ रेस्टिट्यूशन क्या है? कोफिशिएंट ऑफ रेस्टिट्यूशन एक एक्सपेरिमेंटल फिनोमेना है, एक एक्सपेरिमेंटल क्वांटिटी है, विच वी यूज टू मेजर द इम्पैक्ट ऑफ कोलिजन. कि किसी पर्टिकुलर कोलिजन से, ठीक है, इसे हिंदी में संगठ भी बोलते हैं, भिड़ंत. तो किसी पर्टिकुलर कोलिजन का क्या इम्पैक्ट है एक्सपेरिमेंटली, उस क्वांटिटी को कैसे ऑब्जर्व करेंगे, बाय द कोफिशिएंट ऑफ रेस्टिट्यूशन. ठीक है. सो कोफिशिएंट ऑफ रेस्टिट्यूशन इज अ फिजिकल पैरामीटर to measure the impact of collision. ठीक है. So as you can see in the definition also, the coefficient of restitution is an experimental quantity used to represent the nature of collision between the object, and it is given by the ratio of velocity of separation to the velocity of approach. Okay. This velocity of separation is also a relative velocity. and velocity of approach is also a relative velocity. So you can see here there are two balls. Before collision, they having a velocity of u1 vector and u2 vector, in which u1 is greater than u2 vector. Okay. So this is the velocity before collision. तो उसे कैसे लिखेंगे? u1 vector minus u2 vector. Okay. This is the velocity of approach because these two balls are approaching to each other to have a collision. And after collision, they are separating from each other. So that is why this velocity is termed as velocity of separation. इसे हम कैसे लिखेंगे? It will be v2 vector minus v1 vector. ठीक है? Basically, what we are doing, we are observing the velocity of u2 or this ball 2 with respect to this ball 1. ठीक है? Now, so E is given by E is a unitless quantity, dimensionless quantity, is given by v2 vector minus v1 vector divided by u1 vector minus u2. Okay. Now, based on this, we need to derive these formula. I have written it directly. There is no need of derivation. So what we will do, we can have, I'll show you the concept how we have derived it. So we know that in a collision, momentum is conserved. Momentum is conserved. If momentum is conserved, let's say we take the example of the previous one. They are having a velocity of u1 vector, u2 vector. And after collision, the velocity is interchanged. This is v1 velocity, v2 velocity. Okay. This is before collision. And this is after collision. So if you apply the momentum conservation, it will be m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. And we do not know what kind of collision is this. So to have the nature of collision, we apply the concept of coefficient of restitution, which will be given by v2 vector minus v1 vector divided by u1 vector minus u2 vector. By combining these two equations or by solving these two equations, we will have the velocity, final velocity of approach of particle 1, sorry, velocity of separation of particle 1 and velocity of separation of particle 2. Okay, as I have written in the concept here. So that is the concept behind it. Now V1 is simply you can remember by this is 1 V1. So initially you will have M1, then M2. So the formula or the trick to remember is 1 1. So suppose we want to write for V1, it will be M1 minus EM2 divided by total mass into again 1 1 1 U1 vector plus this is 1 1 and 2. Again इसमें क्या आएगा M2. This 2 represent M2. M1 plus M2 into U. M2 के साथ U2, M1 के साथ U. So similarly for V2, you can remember it for 2 1 1. Just opposite. Want to write V2? Right, M2 minus EM1 upon total mass into what will come? 2 means U2 vector into then 1 means M1 into 1 plus E divided by capital M into U1 vector. So this is the trick to remember these formula. Loss of kinetic energy is very simple. 1 by 2 M1 M2 by M1 plus M2 into U1 vector minus U2 vector का whole square into 1 minus E का square. Okay. Now there is a different values for different types of collision. Let me show you here. For elastic collision, so as I have discussed, there is no change in kinetic energy, no loss in kinetic energy. So we can say the coefficient of restitution is 1 for elastic collision. For inelastic collision, the coefficient of restitution is less than 1. And for perfectly inelastic collision, the coefficient of restitution is 0, which means E is equals to what? V2 vector minus V1 vector divided by U1 minus U2. If E is 0, then we can say V2 vector is equals to V1 vector, which means after collision, suppose these are the two balls. After collision, there is a single body which is moved because both have the same velocity. So the object will stick to each other and then move with a common velocity. Okay? Clear? You can apply these values of E in these equation to get the final velocity and change in kinetic energy. So suppose if you put E is equals to 1, this 1 minus 1 will become 0 and this vanishes all this expression. So delta K will become 0, which ultimately shows that there is no loss of kinetic energy and represent the elastic quality. Okay. Now, try to solve this question. Two particles of mass 1 kg and 2 kg are moving with speed 2 meter per second and 5 meter per second as shown in figure. Now, speed are opposite to each other. They collide perfectly inelastic. Find their final velocity and the loss in kinetic energy. So simply we can apply the momentum conservation here, which is P initial is equals to, these are the two balls. The velocity of this ball is 2 meter per second and this is for 5 meter per second. This is 1 kg and this is 2 kg. Let me recall it. 1 kg having 2 meter per second velocity, 2 kg having 5 meter per second velocity. 1 kg, 2 meter per second, 2 kg, 5 meter per second. Okay. Now, so there is no external force also in this case. We can conserve the angular momentum and the linear momentum of the system. So P initial is equals to P final. Initially, they are moving with this velocity and the collision is perfectly inelastic, which means finally they will stick to each other and move with a common velocity. So initial is M1 U1 plus M2 U2 is equals to final will become M1 plus M2 into V. Now, M1 is 1 kg, speed is 2 meter per second. I am taking this direction as positive and this direction as negative. So 1 into 2 minus 2 into 5 is equals to 1 plus 2 is 3 V. This will become 2 minus 5 to the 10 is 10 V. So V will become minus 8 by 3 meter per second, which means they will finally stick to each other and move in this direction. Okay. Now, what is the loss of kinetic energy? So you can have the kinetic energy of the system initially. K initial is 1 by 2 M1 V1 square plus M2 V2 square. And finally, 1 by 2 M1 plus M2 with a common velocity V square. And then you can take the difference also. In that way also you can calculate the velocity or the change in kinetic energy or the loss in kinetic energy. And the final formula we have as delta K is 1 by 2 m1 m2 by m1 plus m2 into u1 minus u2 whole square 1 minus e square. And for perfectly inelastic collision, e is 1. Sorry, e is 0. So 1 minus 0 is 1. Put the value here. 1 by 2. 1 into 2 divided by 3. u1 minus u2 will become 3. Square is 9. Okay. 3 3s are 9. 2 and 2 will also cancel. So 3 joule is the loss in kinetic energy. I hope that you enjoyed this session. And if anyone has any kind of doubt, you can ask right now. Otherwise, the lecture is being over. Thank you so much for being attentive and being responsive. Bye bye. Take care of yourself.